Hey, fifth grade, it's Mrs. Whirl. I'm out here on this breezy, sunny day to show you that I'm going to try to create a garden in my backyard. And I have a major problem though. I have to figure out how much topsoil to buy for my garden. I'm not very good at growing things, so this is my first time trying. So I'm out here measuring how wide and how long I want my garden to be. So I was thinking it should be 3.5 feet by 2 feet, 2.5 feet. So I got to figure out the area. So think about our formula that we have for area. We know that it's length times width. So we're going to have to do 3.5 times 2.5 to figure out how much area my garden will be covering so I can figure out how much topsoil. So I want you to see the area here. This is the area I'm thinking right in front of our shed, and you're going to help me figure out what the area would be for my topsoil. So we can use this kind of a problem in pretty much any area problem, but what we've been used to has just been a whole number times a whole number. So now we're going to be bringing in the fraction part of it as well. So let's look at how to solve this. I start out with having my formula for area, which is length times width. And then I have my problem written 3.5 times 2.5. Now, it's easy enough to multiply two whole numbers, and it's easy enough to multiply two fractions, but clearly the best way to do it is to change both of these mixed numbers into improper fractions. So then all you have to do is multiply two improper fractions, two fractions. So we know that's easy enough. So just in case you forget, here's a quick reminder on how to do that. I like to write my little multiplication and addition signs like that, remember? 2 times 3 is 6. 6 plus 1 is 7. So I have 7 halves. 7 halves is another name for 3.5. And then I'm going to do the same for 2.5, and that would be 5 halves. So you'll look over here to my picture, you'll notice that I have 7 going down the side here, 7 boxes, and then 5 going across the top for the width. So this picture is symbolizing my fraction problem. So you can draw a picture, but I prefer just solving it through because it's just easier for me. So whatever you prefer. But you need to make sure you have the boxes that correspond with the number with the numerator. So now I'm going to multiply this problem out and get the answer. And if I counted all these boxes, I would get 35, but I should just multiply 7 times 5. That's easier for me, so I'm going to get 35. And with multiplication, we know we want to multiply both of our denominators. So 2 times 2 is 4. Even though they're the same, it might trick you because of addition and subtraction, you wanting them to be the same. But multiplying, you can multiply any of them. So I have 35 fourths. We know that's an improper fraction, so we're going to do our division. And I'm going to put my 35 as the dividend and my 4 as the divisor. 4 goes into 35 8 times, so 8 is my whole number. And then my fraction remainder is 3/4. So my answer is going to be 8 3/4 feet. That makes sense to me. Oh, and I don't want to forget squared. 8 3/4 feet squared. Or square feet. That would be another way you can put it. Square, SQ, feet. Or if you even want to write out the word square, that would be great to me. So that looks good to me. This area that I'm covering with my topsoil is going to be 8 3/4 feet, square feet. So I'm going to probably get about 9. And that makes sense to me because if I rounded these, I would get about 9 as well. So that's what I'll be ending up buying. So here's another problem that you should try. Try it along with me. So when I'm solving this problem, I'm going to be multiplying 1 2/3 times 1 1/3, and I'm going to turn all of them to improper fractions. And if you want to do it on your own, you can go ahead and do it and then check my work at the end. 5/3 times 4/3. So they're both thirds, but that doesn't mean that I'm going to change anything. If I want to draw a box for it, I would draw 5 down and 4 across to go with my numerators. And when I count these up, I would get 20. 5 times 4 is 20, and 3 times 3 is 9. So I have 20 ninths, and I'm going to turn that into my division problem. because I need it to be a mixed number, and I will get 2/9. And 2 and 9 has nothing in common, so that is going to be my answer because that is in simplest form. Here's one more for you to try. If you would like to try this one on your own, please pause the video. If not, do it along with me here. So I'm going to change these to improper fractions so I'm able to multiply them easier. So 5 times 1 is 5 plus 3 is 8, 8/5. And I'm going to be multiplying 8/5 times, let's see, 4 times 2 is 8 plus 3 is 11, 11/4. So now I'm going to solve it through. 8 times 11 is 88, and 20 times, or I gave you the answer there, 5 times 4 is 20. Now I have my division problem to make it a true mixed number. How many 20s go into 88? Well, that's simple, it's 4. And my remainder is 8/20. Now, do you guys know that this is not in simplest form? I need to simplify it. So I need to think about what 8 and 20 have in common. Well, I know they have 2 in common, but I'm thinking they might have something else. With 8, 2 times 4 is a fact. Let's try the 4. Yeah, 4 makes sense. So 8/20 divided by 4. And I'm going to get 2/10. Oh, no, wait, 2/5. I'm sorry. Woo, silly mistake. See how easy it is to make a silly mistake? So that should be fifths. So my final answer would be 4 2/5. Do you see how much work is involved with these problems? It really is helpful if you circle them or put the final answer in a box. That way you know that's the final answer, it's the simplified answer, and that way I can see your work and know your answer as well. So I hope you enjoyed my flip lesson. We're going to be working on this for tomorrow, and we'll be finding the area.